for screening. So basically, this is the incidence of thalassemia. In Malaysia, I think previous speaker also mentioned about 4 to 6.8% of beta thalassemia in the prevalence in our populations, but this is actually describe the prevalence in Southeast Asia. We are actually, around 4 to 6.8, but some of the study mentioning about 5.8%. This is basically a study from Sabah, which is they study different populations, and actually the prevalence or the incidence of reported literature sometimes different because a different cohort of patients being studied and the denominator also different, so that we have varies of prevalence in our populations. So our prevalence in Southeast Asia actually similar with Thailand and Indonesia, we have highest prevalence of thalassemia. And we expect some, historically, when we discuss about thalassemia, it's more common in our populations, but emerging, and currently we can see also in area that lowest prevalent like Northern Europe and Northern America, we can have the changing in pattern of epidemiology due to migration, due to mixed marriage, and also prevention program. It's affect the prevalence and also the incidence of thalassemia. So in Malaysia, we have 32.6 million population that we have a diverse ethnic group. We have in Peninsular Malaysia, a majority of us are Malays, and followed by, in Sabah, indigenous group of Kadal Dusun, among the commonest in Sarawak is Iban. And reported also in this paper by Professor Zulfalim, the HBE prevalence is actually around 3 to 40% actually in our population, and 4 to 5.5 and 5% of Malaysian population were reported to be carrier for alpha and beta thalassemia. So this figure actually summarizes the difference between mutation spectrum among Malaysian population. This one we can see in Peninsular Malaysia, most of us actually the registered patient are Malay, which is more commonly we see HBE beta thalassemia rather than in Sabah. We can see most registered patient is actually Kadazan or indigenous group, and the diagnosis is more toward beta zero thalassemia, which is Filipino deletion. And in Sarawak, interestingly, I think what is unique among Iban is actually they carry more alpha determinant rather than beta. That's why the incidence of beta thalassemia among Iban is low in Sarawak. So their prevalence and also the genotype almost similar with Peninsular Malaysia in Sarawak, but totally different in Sabah. So, as mentioned by Dr. Nora, Selangor is actually the second highest incidence of registered patients of thalassemia. The champion is Sabah, and also Kedah is the third state that have high incidence of thalassemia. So this is report Laporan Tahunan 2019 by BPKK. We can see here basically in Sabah, most of them actually pembawa beta, 1,266. In Selangor, most of them reported as pembawa A, and also in Kedah also pembawa A is quite high numbers. Yeah. So we proceed with databases that we use. Actually, I think fair enough for me to describe a little bit on database and also a little bit on how we classify the variant, because our report will provide the details and variant, especially if we found any new variant from the patients. So a few databases available in the website, which is the most we use HBVAR and also Itanet. I reported 953 of HBB gene and 850 of HBA1 and HBA2 variant in HBVAR. And in Istanbul, I think the numbers is a bit different, 3,000, because of they consider the delta, the beta, gamma, all the variants is included. And in Malaysian population, we have this Malaysian Mode of Human Variant Project databases. Basically, we need to have, we need password to register and to access the database, but it's available. So for guideline for variant classification, how actually we classify the variant based on this ACMG guideline. This is published in 2015, ACMG AMP guideline. So actually not every disease, using this classification, but in thalassemia we are using this. Why we need to use this? Because of, I think, for standardization, and also after 2015, they published this this guideline. A few of working group emerged to classify the variant based on the respective expert panel. For example, in thalassemia, we have expert curator or expert panel from mainly from Cyprus, and few of them are from Malaysia. And they actually curate a few variants. If we want to send them a new variant, we can send to them, and they will curate for us whether this variant is actually pathogenic or benign variant. So why actually we need to classify our variant? Because even in the literature, we can see here the number of conflicting interests is quite high. When we see two-star status in ClinVar, you can see here, if you search ClinVar to search for that particular mutation, you can see two-star here. What is meant by two-star? More than two submitters submitted the same interpretation. For example, in this HBB gene, basically, even though they are publishing the data, still, two-star status, the conflicting interpretation is 52. This is, two-star is considered the only curate its variant. So just imagine if this is one star or no star at all. So we need to use it, carefully, basically, okay, with this interpretation. That's why if we have any interesting case or a new variant that we want to classify, then when we search in the literature, it's contradictory with whatever other population reported, we will report to them and try to classify the variant. Okay. So a little bit on how we classify the variant. Sometimes we do ask clinician or we do ask family medicine to provide us more samples. For example, parent sample and sibling sample. For example, if we have a case of so-called novel variant, we are not sure whether the variant is benign because usually novel variant occur in 3. So we can see if the occurrence of that particular variant in 3, we can just say that even though the disease is normal, we cannot say that that is actually a benign variant before we classify. So one other thing that we look is actually history of whether this is actually de novo mutations. So we can study based on genotyping of the parent. We can study the segregation data. Whether we need to search in our population whether the mutation actually has occurred with other pathogenic variant. For example, one new variant when they occurrence in another pathogenic variant, for example HBE with the new variant, and cause a symptom. So we may say that this is actually a pathogenic variant rather than benign. So for minimum, we need at least 3 cases to see that is actually benign variant based on the indices and also few other parameters like in silico or functional data. Okay, so I think we proceed with the mutation spectrum. I did a literature search to see what is our current status for mapping. Few of the quite a number of publications on mutation spectrum among Malaysian population. We go first. I think we go by Malaysia as overall. Then I try to focus on each state. So this is a paper published by our team in Shazwa et al. From IMR. This is paper in 2012. This paper basically, the objective is to study and design a rapid and simple PCR approach to characterize beta thalassemia among our population. Because in 2012, I think not many reported case on mutation spectrum. Previously, we are using 6 panel on PCR to genotype the patients. So I think it's very time consuming, it's laborious, and because of this paper, I think they come up with most common mutation among Malaysian and design one on PCR. Okay. So at that time, we put the indices of MCH of below 27 and MCV of 83. and the A2 exceed 3.4, and any A2 level more than 10, basically for codon 26 HBE. So actually this is the findings. They found that codon 26 is most common population among Malaysian, among Malay, and then proceed followed by IBS 15, 37 patient, and IBS 11. Yeah, this is all in Malay. And codon 41, 42 actually we know that it's more common among Chinese. Yeah, many literature found that codon 41, 42 is among most common beta 0 mutation among Chinese. And also they found also codon 26 in HBE in Chinese. And this is a paper from Professor Zifalil. They mentioned just now, I already mentioned this, up to 40% HBE carrier. And they nicely summarize the ethnicity and the common mutations among each ethnicity. Actually, more or less the same. In Malay, typically, there is about codon 19, HB Malay, IBS 15, IBS 11, and poly A. This is common mutation among Malay populations. And in Chinese, codon 41, 42, and IBS 2654, and also minus 28. This is all actually beta 0 mutations, and also this one, IBS 15, beta plus severe mutations. And in India, basically, it's very rare to have the incident of thalassemia, but we can see codon 43 in India. And in Sabahan, I think everyone knows beta 0 Filipino is most common in Filipino, and in Sarawakian also Filipino division. And alpha thalassemia, as mentioned by Dr. Noor Isah, 3.7 is more common among Malay and Southeast Asia, followed by Southeast Asia and Cotton Spring. But in Chinese, typically, many literature reported C deletion is common among Chinese population. And Indian, usually we got 3.7 basically. And Sabahan, 3.7. Sarawak is actually Filipino. And orang asli, HB Cotton Spring. So this is actually another study by Dr. Rahima. This is also from previously from IMR. They study among Malaysian populations, and the objective of this study is to describe and the distribution of alpha thalassemia allele in different ethnic groups. And they illustrate the hematological changes associated with each phenotype. And they use 5,016 unrelated patients and retrospectively analyze all the data. What are the findings? Actually, similar with previously reported. I think in Malay, 3.7 is more common, and then in Chinese, 29.9%, exceeding the percentage of in Malay C deletion. In Indian, 3.7, as I mentioned before. And I think everything is about the same. Similarly to UKM group, Prof. Azma also published a paper on a mutation spectrum of alpha thalassemia among Malay, Chinese, and Indian. Only thing that different between two papers is actually the findings actually they found majority of them is actually instead of Malay having alpha determinant, they found Chinese carry that more alpha determinant than Malay. But maybe it's due to the sample, the size of the sample in spring. And this is also a group from Dr. Rahima. A similar pattern in Malay, they found 3.7. In Chinese, most of them are 5. C deletion, and also Cotton Spring more commonly among Malay. Okay, this is actually the report landscape of HBE beta thalassemia. We report this study. Basically, the aim of this study to describe the genomic landscape of HBE beta thalassemia among Malaysian population. So we analyzed 520 samples of HBE beta thalassemia from 2011 to 2019. We exclude few cases like history of transfusion and also pregnancy because it will affect the F level and also the A2 level because of the history of transfusion. So these are the findings. Most of Malaysians carry HBE beta plus. This is because I think during the analysis we categorized IBS 1.5 in the beta plus. Basically, I think it's best to classify IBS 1.5 in beta 0 because among HBE beta thalassemia, majority of them are TTP and majority of IBS 1.5 HBE presented with TTP. But during this analysis, we classify IBS 1.5 as beta plus severe. So most of them are actually E beta plus, followed by E beta 0, E delta beta and HPFH and variant. So what are the things involved in HBE beta thalassemia? As we expect, because IBS 1.5 is common among our population, so the combination is HBE and IBS 1.5. And HBE together with COVID-19 also combined and poly-A. So for beta 0, common mutation involved in HBE is Filipino, IBS, I don't know what it's mean. IBS 1.1, sorry, IBS 1.1 is common, population, so it's common in HBE also. HBE codon 41, 42, and HBE codon 17, and HBE codon 35. This is among the commonest mutation involved in beta 0 HBE. So I'm sorry because I think too small for you guys to see this, but I think this is HBE beta plus. This is HBE beta 0, this is beta plus, this is HBE HPFH. We can see here actually HBE beta 0 typically will present with higher F level. Okay, when we see the F is significantly high as compared to beta plus, which is, we can see beta plus here, like codon 19 and also codon 20 poly-A. This is only 4.9. It's actually very low, 4.9, but yet it's actually HBE poly-A. Yeah, with the A2 level of 5.05, and actually this is quite interesting finding because this is HBE compound with poly-A, as Dr. Munirah mentioned just now. So for IBS 1.5, basically the indices is about similar with beta 0. That's why I think it's better classify the IBS 1.5 as beta 0 phenotype. So this is just a summary on what I presented. This is what mapping that has been done in Malaysia. I think we are not that bad to start with. I think in Kedah, Dr. Hafiza also illustrate studies done in Kedah that that noted that the incidence of alpha also quite high in Kedah and also HBE beta thalassemia. In Terengganu and Kelantan, I think quite unique features there because in Terengganu we have HB Makassar. I will present it later. In Kelantan, I think we have recently published HB Singapore, quite unique in Kelantan population. And this is data that we have mapping for Malay, Chinese, and India. I think maybe you can have a read later. So for Sabah, mutation, but the mutation spectrum in Sabah is not that diverse as Peninsular Malaysia. So very little are found in Sabah. Most of actually data determinant in Sabah is Filipino and poly-A. Just a little bit, so we can expect that borderline cases there is not that many as in Peninsular Malaysia. So in Sarawak, as I mentioned, Iban carry most of alpha thalassemia and the beta 0 CDH is quite common in Sarawak. So with data, basically this is from MTR. I think most of the patients are Malay and most of the diagnosis as expected in all Peninsular Malaysia. I think all the states have HBE beta thalassemia, the highest incidence of HBE as compared to beta thalassemia and HBH. But actually surprisingly HBH quite a numbers, yeah, from the MTR data. And this is actually a preliminary data published from IR. We received most of the case from diagnostic, as mentioned by Dr. Nora, and then from 4, cascade and also antenatal. This is the data on 2017, 2021. We did a retrospective analysis on the data received from Selangor. So most of the sample are Malay, followed by Chinese and others, and so Indian. So I analyzed based on ethnicity, quite similar findings. You can see here, but in Selangor, because we are not separate based on A2 level, poly A typically presented with borderline A2. So I think the incident of borderline is quite a number in Selangor. So the most incident of data determiner is poly A, followed by IBS 1.5 and 1.1. This is expected finding for beta 0 thalassemia. And this is the variant. I'm going to touch but if I have time, I want to talk a bit on HB Richmond because HB Richmond is actually can mimic or mask HBQ Thailand. So this is quite recent because previously we have not, this is quite recent findings. Okay? And HBE, the thalassemia in Selangor itself, as I mentioned from our study, it's quite similar, which was 1.5 HBE among the common, and then HBE Malay, HBE 1.1 and 1442. Yeah. So for zygous, mainly we expect IBS 1.5 with metacycles per number in Selangor, and homozygous from Malay, and also this is a compound poly A Richmond. And for HPFH in Malay, similar, and Washington, and local Washington, Boston. Okay. Actually, India also quite common among Malay. So based on Chinese ethnicity as expected, codon 4142, right? So we can see here, codon 4142 is among common names, 654 minus 28. This is all expected, and also quite common also we see here in, besides Sarawak, beta 0C is quite, because Dr. Munira has beautifully elaborated C deletion. This is unique features of C deletion, you should note that. So you should recognize this beta 0C deletion by HB analysis. At least we can suspect that. So for Chinese, basically Chinese deletions at the beta and HBF6 common among Chinese. And for Indian ethnicity, basically we have Sikh, as expected, Sikh is common among Indian. So for Kedah, I'm not sure whether I said that. Alright, so I just want to be on Kedah because Dr. Hafizah has elaborated this, but most of the association is either thalassemia, so and the populations are mainly Malay, registered and NPR. So we can see also this is presented by Dr. Hafizah. They beautifully do a mapping for, so I think preferably, if every state can have this, I think we can plan it. So it's really helping to a policymaker in terms of costing and also budgeting. Yeah. So this is also this is actually the poster from Dr. Hafizah and Hafizah et al. They study on borderline cases from Kedah. So basically, as we expect, the Nemo also elaborated this, in borderline cases, usually we found mild beta plus thalassemia. So they found codon 19 among the highest of borderline beta thalassemia, followed by poly A. The findings quite similar with us, only the frequency are a little bit different. And this study, the study population is include 3.3 to 3.9. We did a study on borderline from 3.0 to 3.9. Okay. And actually, this is quite interesting. Also, it's quite supported by our study also. In 3.7 is actually up to 3.7. So, I mean, so in borderline HbA2, sometimes we sequence the thalassemia, we don't have anything. We sequence alpha, so I mean, we did an alpha panel, then we found 3.7. It's quite common also in borderline cases. So, okay, this is not. I'm not going to discuss this. Okay, this is Kelantan paper because I think Dr. Zulaiha is here. This is, a few words in the paper, so we subject on people for borderline. Basically, in this paper, they suggest us they propose to reduce the cutoff to 3.0. However, actually, this paper are a bit lack on description on what are the mutations found in 3.0. So basically, they found commonness. They did a study from 3.0 to 3.9. This is the type of beta mutation that commonly found in Kelantan. Yeah, in Kelantan, they found HB value, something like that, and then followed by the S1. That's one five, sorry, 1.5, and then poly A. So this is quite surprising. I mean, this is quite unexpected findings because typically IBS 1.5 doesn't present with borderline. So if you have this sample, maybe we should think about possible delta variant, also a possible coinherence with alpha or beta, together with beta. So 1.5 is quite uncommon in borderline cases. So, okay, I'm also not present the Tunggano case, but Tunggano actually published quite a number of samples. But I think, okay, this one I need to highlight a bit on borderline E2 cases in our local setting. I'll just present in this program because in this study, we did a study from A2 level 3.0 to 3.4. And 3.5 to 3.9. This is all hypochromic macrocytic. The other arms is actually normochromic macrocytic. This one I'm not presenting. So a bit on CD and CH, but into level of 3.3 to 3.9. You can see here, even though it's a bit lower, but the mutation involved is quite significant, which is we can see the yellow one is K+1. This is beta plus thalassemia. In heterozygous, it's meant to have a trait, there's a traceable trait. Now, compared to heterozygous, yes, I agree with Dr. Munira, we have the cases from HKL compared with K+1 with other pathogenic virus presented as TDP. So we not sure other modifiers that involved in this sample. And then COVID-19 also quite common in, found in 3.6 E2 level and also poly E. This is normal MCV MCH plus borderline E2. Okay. For abnormal MCV MCH, we need 3.0 to 3.4. Typically, we are not saying it because typically cut off 3.3. So what are the findings at 3.0 to 3.4? We can see actually majority is still normal. Yeah, the green one is still normal. And then we can have beta mutations in about 21% in the findings. So what are the mutations involved? 3.0 is actually very is actually poly A. So I'm not sure whether we want to support the suggested by 3.2 is real to screen for beta thalassemia. But at the 3.3 and 3.4, this one quite a number of sample positive mutation, which is K+1, and also the green bar is actually poly A. Okay? So it's quite common we see one beta plus poly A and K+1 in 3.3 and 3.4 percentage of group, which is actually more finding is going to be analyzed 3.5 to 3.9. So this is usually we say example for the of course, some people some people will argue why we not increase our cutoff to 3.5. But if you remember the previous slide, we can use that K+1 and poly E if we increase our cutoff to this. But of course, it's really depends on resources. Yeah. So this is as compared to the previous slide, majority have significant findings. More than 50% have significant findings if we have cut off 2.5 to 2.9. So this is alpha mutation. Just now I mentioned at 3.7 we found 3.7 deletion. Even how you found 3.9, also patient had 3.7 deletion. For this mutation, this is common findings in our findings, which is actually the purple bar is poly E, followed by the green bar is actually COVID-19, and then +1, and also +1, and also other mutations. Yeah? But typically it's a beta plus thalassemia. And this is the cutoff of 3.3 that I mentioned. Actually, if we take 3.3 as a cutoff, that's just 85%, but the specificity is not that great, it's only 50%. But by lowering the cutoff, usually we have higher sensitivity but lower specificity. It really depends on the decimator what to decide, because this is the gray area that we should decide. Okay. All right, I think so I already mentioned what are unique basically I tend to qualify already described by Dr. Munira, directed by Dr. Lucina. And then I just want to highlight this is HB Makassar. I think previously if someone will highlight this also. This is common variant among Malay ethnicity, and the diagnosis challenge as it's imitate HBS. So I think they saw many patients presented HB analysis of us, wherein maybe they will think about what with Makassar rather than Sikho. So that maybe you can actually use this to guide on sending whether you want to send to MR or you want to send to HKM. Okay? So this is benign variant. It's called Sikho. Sikho is pathogenic and Makassar is benign. And Singapore is actually a type of HBJ more common among Kelantan, Malay Kelantan. So the pathologist from Kelantan, maybe the type of HBJ you can see is probably HB Singapore. And actually this one was reported as pathogenic variant by internet, but I think we try to send to them that we propose to classify this as benign because we have serious numbers of cases that behave like benign variant. We can have the answer. I think this one also has been discussed by Dr. Munira in the situation. Just want to highlight a bit on Richmond. Maybe I have another 2 minutes. So HB Richmond, this patient is actually 16 years old from KK Lantaman to Implant. Asymptomatic campus screening program, and we can see here HB normal with mild hypophobic hypercytosis. I'm sorry, I only have this HPLC. We cannot extract the CE, but actually the finding is S window in HPLC and F in CE. So we can see here the differential at that time, they want to roll out HBQ Thailand, and the differential will be HB top. But typically HB top presented with high affinity hemoglobin, higher hemoglobin level. So this actually we found actually HB Richmond. This is as compared to Thailand. Thailand is actually alpha variant, and Richmond is actually beta variant. So if HB analysis diagnosis of HB Thailand, sometimes we direct send the sample for alpha sequencing. And if the result come out negative, sometimes if an experienced doctor we see that maybe this is actually one sample or common. But it's actually when we did a beta mutation, we found HB Richmond in this patient. So, also HB Richmond, but combined with other beta plus, we can see here the A2 level a little bit high. A2 4.5, the F level is high at 64, and in HPLC we can see the A2 14.6 and peak at S window. So this one is actually the molecule combined as HB Richmond and HBE. So interestingly we found only in bumping. Yeah? The cases is actually most of them are in bumping. So all the family, I've listed all the family here, five patients with HB Richmond. We can see it later. So by that, I thank you. Untuk Dr. for the informative talk, Ashmana invite Rashida Muhammad to present a token of appreciation to Dr. Rafiza. Please welcome them on the stage. Thank you, doctors. Our journey just has far been intellectually exciting. It is now time to replenish our energy. Kindly be informed that food is provided for all participants. I can see that everyone is smiling now. There are tables outside the auditorium which are specially prepared for all specialists. So please kindly help yourself to the table later. During our lunch break, do enjoy a meal and take the opportunity to connect with other participants. Prayer room and washrooms are located on the same level. Please be back to the auditorium by 2:30 p.m. to resume our program. That's all for now. Please enjoy your lunch and I will see you back at 2:30 p.m. Thank you so much. Aduh, tapi kenapa tak keluar?